I'm Bill Kinney. This is video number 38 in a series on foundations of arithmetic, algebra, and graphing. Part 7 of a sub-series on exponents, roots, and logarithms with an emphasis on calculator usage. We've been looking at some basic kinds of investment questions. In this video, I hope to answer this question here. What interest rate is required for your money to double in 12 years? The reason I'm bringing up this question is not only is it an application of exponents, but it also helps us motivate the idea of what it means to raise a number to a fractional power. We decided that 2 to the 1/2 power should mean the same thing as the square root of 2, and by the way, the word root there is part of the title of the subseries, Exponents, Roots, and Logarithms. Square root of 2, the positive square root of 2 is a positive number whose square is 2. What is that number? I have said before that it's irrational. I'll say it again. Let's see how it turns out on a calculator. On this calculator, there's a square root symbol right there at the bottom. So I've got to hit the second function and press that button there. And now you see a square root up here. I put a 2 in there. I don't actually have to close off the parentheses, but I think I will anyway. 1.414213562, is that it? Well, you should remember from another video that that's actually going to be an irrational number. This decimal expansion is going to go on forever and ever without a repeating pattern. But if I do square that number, I get 2. Now that doesn't mean if you square this truncated number, 1.414213562, that it definitely gives you 2. It doesn't. What's the resolution of that paradox there? Well, the calculator is keeping more decimal places of memory than you see up here, and so that's why we got 2 there, although the calculator really is just rounding there, because anytime you truncate that decimal, it's not going to be the exact square root of 2, and so when you square it, you won't get exactly 2, but close enough that the calculator rounds it to 2. However, if I trunk it to what I see there, then we don't get exactly 2. Even on the calculator screen. What about other roots? Well, maybe before I go into other roots, let me just illustrate also that if I raise 2 to the 1/2 power on the calculator, like that, I do get the same thing. That is the square root of 2. What about other kinds of roots? Third roots and fourth roots and fifth roots, or mth roots, where m could be 2, 3, 4, 5, 6, etc. We're going to define b to the 1 over m power to be the mth root of b, where b is a non-negative number and m is a positive integer. The first root of b would just be b itself. What does this mean? It means when I raise this number to the mth power, I get b. Well, it's kind of abstract. Let's do some examples here. Evidently, for example, 7 to the 1/8 power should be the 8th root of 7. In other words, this should be a number so that when I raise it to the 8th power, I get 7. What number is that? If you didn't have some sort of exponent feature on your calculator, or excuse me, if you for some reason couldn't do fractional exponents or something in your calculator, you'd have to just experiment with it. Maybe you'd guess 1.2 is the answer. Raise that to the 8th power, and you see that you're wrong, it's too small. So guess 1.4 maybe, 1.4 to the 8th power. That's too big. It jumps pretty quickly. 1.3 to the 8th. That's getting pretty close. Evidently the answer is pretty close to 1.3, a little less than 1.3. But it's quicker to just do, well, I'm supposed to get close to 7 here, not 8, excuse me. But it'll still be between 1.2 and 1.3. If I want to get the answer, I can just type in 7 to the 1/8 power. Here's an approximation for the 8th root of 7, 1.275373107. If I raise that to the 8th power, up to calculator approximation, I get 7. It is in fact an irrational number, and so if I truncate it, like that. Probably this will not give me exactly 7. Yep, a little bit more. So just keep those kinds of things in mind in thinking about this. How are we going to use it to solve the problem now? That's the basic idea. I would encourage you to try more examples with your calculator and make sure you understand this concept. And how are we gonna now use it to solve the problem? What interest rate is required for your money to double in 12 years? And again, as with the previous problem, it doesn't matter how much money you start with, though it might be helpful to imagine a certain amount. To keep it real simple, in fact, let's imagine we deposit $1. So $1 is going to be in the bank. What kind of interest rate is going to be required for the money to double in 12 years? You could experiment. I know a 2% interest rate is not going to do it because that took 35 years to double from a couple videos ago. So try a bigger interest rate like 4%. Will it double in 12 years? Nope, not up to 2 there. Try 5%. Nope, not up to 2. Try 6%. There's a little bit past 2. The answer evidently is going to be pretty close to 6%. If you don't remember why I'm taking the 1.04 and 1.05 and 1.06 to represent 4, 5, and 6% with bank deposits here, you'll want to go back and look at a couple videos ago. Let's look at this one here. What we're hoping for is an answer of 2. What number, a little bit bigger than 1, will be such that if I raise it to the 12th power, I will get 2? Well, that's just what I've been talking about. 2 to the 1/12th power is going to be a symbolic form of the answer. The 12th root of 2 is going to be a number a little bit bigger than 1, such that when I raise it to the 12th power, I get 2. 2 to the 1/12th power is what I need. There we go. And if you look at that, you realize that that means the interest rate that I require, the answer to this problem, is going to be about 5.95%. That's the answer to this problem, about 5.95%. How would you do this on another kind of calculator? It's a little trickier on some other kinds of calculators to do this. 2 to the 1/12th. What you probably want to do is figure out 1/12 first. 1 divided by 12. Looks like it's 0.083 repeating. Now you could certainly write that number down and now do 2 to the 0.083 repeating power. To get the same answer, about 5.95%. But sometimes you might not want to write it down, and sometimes it might be more complicated to remember. And is there another way? These types of calculators typically have memory. And you typically use a button that might say STO for your memory. That stands for store. Some calculators just have a little bit of memory, and you can just hit store to keep it in memory. This calculator has more memory than most, and so I have to actually, after I press STO, I need to press a digit here. Go ahead and press 0, and that's going to store that number in this calculator in a registry that's marked by a 0, if you will. I could have pressed one of the other numbers as well. Now I can take 2, press my Y to the X button, and recall RCL, the number that's stored in this registry that's labeled with the digit 0. There you go. There we go. There's the answer, 5.95% approximately. I'll do that again real quick. Actually, let me just show you. If I press RCL and press 0, you see the number is stored in that registry. If I press some other number, like 1. After pressing RCL, nothing is stored, 0 is stored. So that's what I have to do on this calculator. You might have a simpler calculator where just one number can be stored, and STO would be storing that one number, and RCL would be recalling that one number.